All right, let's jump right into this explainer. Today, we're doing something pretty wild. We are going to bridge the massive 3 billion year history of biological evolution with the cultural evolution of language and literature. I know, it sounds like a massive timeline to wrap our heads around, right? But stick with me. By looking at how our biology shaped us and then how our tools of communication adapted in the exact same way, we can see a really beautiful continuous story of adaptation. To do this, we're going to follow a 5-step journey. The grand tree of life, the path to humanity, the roots of Sinhala, the evolving Sinhala script, and finally, modernizing the literary heritage. Section 1, the grand tree of life. Let's start at the very beginning and look at the core biological principles that shape all life on Earth. Okay, so the absolute crucial point here is that biological evolution relies on gradual, successful changes that pass from generation to generation. It's basically driven by 3 main engines, right? Natural selection, genetic drift, and mutation. It's all about a population passing down traits that let a species adapt to its environment over vast, almost unimaginable stretches of time. Basically, if a genetic trait works, it survives and it spreads. Section 2. The path to humanity. Now, let's compress time a bit and trace our own specific branch on this evolutionary tree. This timeline brilliantly illustrates our own relatively rapid biological journey. Just look at this. We started as early vertebrates roughly 500 million years ago. From there, we jumped down to mammals around 200 million years ago, primates at 90 million, and African apes between 15 to 12 million years ago. But the absolute critical moment for us, that happens right at the bottom there, 8 to 6 million years ago. That is the exact window when the ancestors of modern humans, Homo sapiens, actually diverged from the lineage of chimpanzees and bonobos. Now, seeing that evolutionary timeline leaves us with a genuinely fascinating question. Once we evolved the biological hardware, the brain capacity, the vocal cords, the motor skills, how exactly did we develop the complex software of human culture and communication? Like, how did we start sharing complex ideas across generations without relying strictly on genetics? Section 3, the roots of Sinhala. This actually brings us perfectly to the concept of linguistic evolution. Because as you'll see, languages evolve very much like biological organisms do. Just like a biological species mutates and adapts over time, the Sinhala language, which by the way is part of the Indo-Aryan subfamily, evolved through some very distinct historical stages. It started with Ilu, transitioned into Proto-Sinhala, adapted further into medieval Sinhala, and finally arrived at the modern Sinhala used in Sri Lanka today. What's super interesting here is that we can literally see linguistic gene transfer in action. Just like different species sometimes cross paths and share traits, languages do the exact same thing through things like contact and trade. Sinhala actually absorbed vocabulary from Dutch, English, Portuguese, Sanskrit, and Tamil. But it didn't just take. It left its own evolutionary footprint on languages thousands of miles away, like McKinney's Patois and McKinney's Portuguese. How cool is that? Section 4. The evolving Sinhala script. Let's move over to the physical script itself and see how the alphabet physically mutated into the form it holds today. The mechanics of this are honestly incredible. Just as humans share a common ancestor with apes, the Sinhala script actually shares a common ancestor with Telugu and Oriya, and that's the Southern Brahmi script. And much like how genetic mutations are influenced by the environment around them, Sinhala was heavily influenced by the Pallava Grantha writing of southern India. It really is a perfect blend of shared ancestry and environmental adaptation. Looking at these historical fragments, like the ancient pottery found in Anuradhapura, is literally like looking at linguistic fossils. I mean, these fragments show the older, raw forms of the alphabet. They definitely possess the baseline DNA of the language, but they're clearly still in their early, primitive visual stages. But as we move forward in time, notice how the characters start to adapt. See how those sharp edges round out? Now, this isn't just random chance. It's an actual physical adaptation to the materials they were using. For instance, writing on palm leaves requires rounded strokes so the leaf itself doesn't tear. It's form following function. You can see the progression continue here as the strokes become much more stylized and uniform. The characters are getting more complex, sure, but they're also becoming visually standardized. And that's absolutely crucial because it allowed for much faster and far more consistent communication across the whole population.
By this stage, the visual DNA of the script is, well, it's nearly fully formed. That elegant, looping, instantly recognizable alphabet that Sinhala speakers use today, it is almost completely defined in these specific historical examples.
And then, finally, we hit a plateau. Right around 1250 AD, the Sinhala script reached a point of evolutionary stability. Once it hit these finalized character forms, the script largely remained unchanged for centuries. The biological equivalent here would basically be a species that's perfectly adapted to its environment, no longer needing radical mutations just to survive. Section 5, modernizing the literary heritage. Because even when a physical script completely stabilizes, the culture and the literature built upon it, those continue to evolve dynamically. A really perfect example of this cultural adaptation is the legendary work of author Martin Wickramasinghe. We can actually track his evolutionary impact on literature right here, starting in 1914 with his novel Leela, then moving to his critical anthology in 1919, and culminating in the 1930s and 40s. So what exactly did he do? Well, he evaluated traditional literary heritage by synthesizing the absolute best in both Indian and Western traditions of literary criticism. Basically, he forced a cultural mutation, which elevated Sinhalese literature to an entirely new standard for the reading public. So, as we wrap up this explainer, we've traced a pretty incredible path together. We started with the biological origins of vertebrates 500 million years ago, zoomed right down to the ancient pottery fragments of Anuradhapura, all the way to modern computer Unicode blocks for the Sinhala language. And that leaves us with one massive, totally provocative question to ponder today. As our languages become deeply integrated into software and digital code, how will these new, purely digital environments drive the next phase of human and cultural evolution? Will our languages continue to mutate, or will technology force a new kind of global stabilization? Definitely something to think about.